Hello everyone, my name is Vikrant Singh and I am going to give a presentation on the topic modulation techniques in communication system. So let's begin. Let's begin with what is modulation. Modulation is a process where one or more properties of a carrier signal, also called as periodic waveform, is varied by a modulating signal and that typically contains information. And as our topic is modulation techniques with communication systems, so let's see how it is essential for communication systems. It is essential in transmission of signal over large distances. It also enables multiplexing and also adjusts the signal frequency, phase, and amplitude to match the transmission medium. So, like this is the carrier signal, and this is the actual information containing with the help of a modulator, and we get the modulating signal as the output. There are various types of modulation, and it is generally divided into analog and digital based on the nature of the message signal and how it used to modify the carrier signal. One example is analog, and another is digital modulation. Analog modulation consists of amplitude modulation, frequency modulation, phase modulation. On the other hand, digital modulation consists of amplitude shift keying, frequency shift keying, phase shift keying, and quadrature amplitude modulation. So let's begin with analog modulation. Analog modulation includes techniques where a signal is modulated using a carrier signal, and the signal and the message signal is analog signal. And like the various types of analog modulation or the examples of analog modulation are amplitude modulation, frequency modulation, and phase modulation. So let's discuss each and every one in detail. First one is amplitude modulation. In amplitude modulation, the carrier wave varies in proportion of the instantaneous amplitude of the modulated signal. It varies on the amplitude part of the signal. The carrier signal is this, and when the modulating signal is met in the modulator, the amplitude modulated signal comes out at this, and the modulator index is AM by AC, and the bandwidth of the signal is twice the angular frequency of the modulating signal. Let's see uses in communication. We can discuss like it is used for long distance audio transmissions as it is very low cost and simple. And but it is susceptible to noise. It's like used in AM radios. And that's why we sometimes hear a lot of disturbances and errors in the noise while listening to radio because it is susceptible to noise and disturbances. The next one is frequency modulation. In frequency modulation, the frequency of the carrier wave is modulated according to the modulated signal. It's the same thing. The carrier signal is this, the modulated signal is this, and we have to find the instantaneous frequency of the FM signal, which comes out at this. So when we plug in the values in the modulator, the output from the modulator is this. And as we saw, there was modulation index in the amplitude modulation also. There's the same in frequency modulation, which comes out as delta F by Fm. The approximated bandwidth can be controlled by the Carson rule, which tells us the bandwidth is twice of delta F and Fm. Uh, As we can see, this is the message signal and this is the carrier signal, and when they are modulated, the output is according to both of them. And we can discuss is like FM radio broadcasting, television audios, two-way radios, as FM provides a high fidelity transmission of speech, which was not possible in AM, and as also it provides very few disturbances and interferences, and which makes it ideal for communicating in critical environments. For example, you have to convey some information which is secret or which cannot be lost during the transmission. It is used in those kind of scenarios. Now we'll go to phase modulation. Similarly, in phase modulation, the carrier signal is very directly at only proportion of the amplitude of the message signal. Now, look, now the phase of the carrier signal is varied. In frequency, it was frequency, and in amplitude modulation, it was amplitude. It is the same thing as we discussed previously, and we get the output modulated signal as this, and where beta is the modulation index. And this is the message signal, and according to carrier wave, it can like change the what are its uses? It's used in like in new Wi-Fi modules, GPS systems, and Bluetooths, as they use a combination of phase modulation with other modulation techniques to transmit data over wireless networks. As PM is used to also encode navigation messages, which are like then interpreted by the GPS receivers. And same in the Bluetooth, it uses phase modulation in combination with frequency modulation and hopping to ensure the data is reliable and it is transmitted over only short distances. So, like we are done with amplitude analog modulation. Now let's move to digital modulation. Digital modulation involves modulating a carrier wave with discrete signals. Discrete signals are like binary signals of 1 and 0. And these methods include amplitude shift keying, frequency shift keying, phase shift keying, and quadrature amplitude modulation. And like we discussed, the main difference between analog modulation and digital modulation is analog modulation is used for transmitting continuous time signals like audio or video. On the other hand, digital modulation is used to transmit digital data over a modern communication systems like internet, Wi-Fi, cellular networks. Like this is the discrete signals of ones and zero, the binary signal, and this is the carrier wave. And then it is modulated according to different methods. Let's begin with amplitude shift keying. In amplitude shift keying, there are the carrier signal is switched between two levels, either one or either zero. This is the carrier signal, and this is the message signal. If it is one, and the bit is one, and zero if the bit is zero. And the output we get is the original signal if the bit is 1 and the signal dies when the bit is 0. Okay. So this is the like schematic diagram for the same. Like this is the sinusoidal carrier, this is the binary message and the output. We can see like when it's 0, the response of the modulated wave is also 0, and when it's 1 it is the original waveform. It's used in optical communication, like optical fiber communication, where the presence of on and off represents binary data. It's also simple and widely used in short range data transmission, like earlier it was used in Ethernets. And it also used in low power radio frequency devices, as it also like takes very less power and it's had low data rate applications. Let's move to frequency shift key. Frequency shift keying or FSK. In FSK, the carrier frequency is shift between two discrete values. Here, the carrier frequency is shifted. So it is the same thing like delta F, the difference between carrier frequency when the bit is uh, a 1 and F naught is when the bit is 0. And delta F is the frequency difference. So, for example, the carrier signal is this, and the binary data is 1 or 0. It depends on whatever the input is. The modulated signal we get is when the bit is 1, we get the uh, frequency when the according to the frequency when the bit was 1, and we get omega naught when according to the when f naught was 0. When the bit was 0 and the value of frequency was f naught. And as similarly, as seen in analog modulation, we can find the bandwidth using the Carson rule, which is like twice of delta f plus fm. It's the like schematic diagram. It finds the difference between them and then outputs them. Like when the signal is one, the frequency is depends when the signal was one, and when it's zero, this is like basically f1 and f naught, the frequency. Its applications are widely in Bluetooth communication, where different frequencies represent binary data of zeros and ones, and it's very robust against interference. On the other hand, it is also used in radio frequency identification (RFID), where the different frequencies shift encode the data sent from the RFID tag to its reader. Now we'll move to phase shift keying. Phase shift keying is when the phase of the carrier signal is changed. Now it is the same, but it is of two different types. One is binary, and other is quadrature. Binary uses only two phase shifts when the phase shifts only then by a 0 and 2 pi, and the other is when if phase shift it has four phase shift quadrature, like from 0 pi by 2, 180 degrees, and 270. Now let's look into binary one. In binary, we only the value of theta b is only for 0 and pi. And the output we get is when it is 0, it is the same signal, and but when it is pi, the signal gets negative output of the original one. And in the quadrature one, we have like four values of 0, pi by 2, pi, and 3 pi by 2. And the output depends on pi by 2. And like this is basically the signal output. And its uses it this is also used in Wi-Fi IEEE 802.11 version, where it is used to encode the data in phase of a carrier signal, and it enables high-speed data transmission with good efficiency. It also uses satellite communication and internet services, where internet services use PSK, quadrature PSK, to efficiently to transmit data over long distances and provides high quality video and audio data signals with minimal bandwidth. Thank you.